Namaste dear students, hope all of you are well. First of all, wishing you a very happy Ganesh Chaturthi. Please be safe at home, keep your family also safe. May Lord Ganesha fulfill your all the dreams and wishes. Actually today I'm going to start something new. So let's come first towards the topic and then we'll move ahead. First come to the point. You know very well atom, right? This is the atom. Here inside the nucleus they are having protons and neutrons, right? And on the orbit they are having electrons, right? So on the first orbit 2 electrons, in the second orbit there are total 8 electrons, in the third orbit it can accommodate 18 but it is 8 electrons only. Now have you ever think that in this atom this electron cloud, because you know very well electron is a dynamic particle. Electron can't stop at one place. So electron is a dynamic particle. So electron will rotate every time it is going to rotate, right? Here, after some time here, after some time here. Means electron is doing revolution around the nucleus and rotation around its own axis, that's called angular momentum, right? Now I just want to say you that have you ever thought inside your mind that this all the electron dense is going towards one side? Means in the symmetrical, just suppose that there are two atoms, right? These both are the atoms, they both are symmetrical, but sometimes you will see the electron clouds are rotating here because electron is always rotating, it is not being stopped at one place. So here also it's rotating continuously, it's rotating. Here also rotating. When the electrons, now to both the electrons, what will happen? Inside this atom, they are having nucleus, that's positive charge, and the electron is negative charge. You know very well, when this negative charge will come here, and this negative charge will come here, so this negative charge and positive charge do interaction that we have studied in overlapping. Have you heard the overlapping word, that hybridization? In that we have already studied why this both the nucleus comes closer to each other, because here the first atom's nucleus and second atom's electron, and second atom nucleus and first atom electrons, because of the electrostatic forces. So inside any of the substance or matter, you know very well solid, liquid and gas, right? So solid are having just small atoms which are very closely and tightly packed to each other, right? Means they are very closely and tightly packed. In liquid they are having some distances, and gases they are have freely too. Means liquids and gases are fluids, and solid intermolecular forces are very tightly packed to each other, right? So here you can see, just think about this atom. As the atom electrons are moving towards one another, so what will happen? The dense of electron will go one side. Are you getting what I mean to say? The dense of electron will go one side. The clouds of electron will move one side, and wherever the clouds of electrons are moving, so this symmetrical atom, here also this symmetrical atom, the electron clouds will arise here, polarity or polarizability. Here both the atoms arise polarizability. So as the atom arise here polarizability, so you can understand the atoms can induce a force. The atoms can induce a force, and you can understand about this matter. So today nothing else, we are going to discuss about the states of matter. It is states of matter, class 11, chapter number 5, NCERT. States of matter. Have you ever thought about these whole concepts, whatever right now I have said you? So there was one scientist, John van der Waal. Have you heard the name John van der Waal? He had given one concept about the chemical bond, as we have already discussed in the previous chapter about the types of chemical bonding. Can you tell me how many types of chemical bonding are there? I hope all of you have remembered about the chemical bonding. In the chemical bonding chapter we have studied also, and we have just studied about that van der Waal is a very weak bond. but this chapter will give you a lot of information about the van der Waal bond. Right? So let's start. First of all, in this topic, you will discuss about the intermolecular forces. Intermolecular forces. What are these intermolecular forces? You know very well. Intermolecular forces induce a polarity. This intermolecular forces induce a polarity. There are total 3 types of this intermolecular forces. First is London force or dispersed force. It is also known as London force. Second one is dipole-dipole force. Dipole-dipole force. And third one is, can you tell me? Dipole-induced force. The first one is also known as dispersion force. Right? So these 3 forces are according to intermolecular forces, and it was given by John van der Waal. You may have heard about the van der Waals forces or van der Waals bond, right? So you know very well that van der Waals bond is a weak bond, right? It is very weak bond. As I have discussed in the chemical bonding chapter also, there are total 6 types of chemical bonding. First is ionic bond, second is covalent bond, third is coordinate bond, fourth is metallic bond, fifth is hydrogen bond, and sixth is van der Waals bond. So in this van der Waals bonds, it is because of the intermolecular forces or intermolecular, you can just understand it is the weakest bond. Now, as I have discussed you about the symmetry of the molecule, just about this is one atom A and another atom B. Got it? So this both the atoms, electrons are rotating or doing the revolution, right? So as you will see in this both the atom, when the electron clouds will be on the left side of A atom, here electron clouds are there, then similarly here clouds will be also there of B atom, means electron clouds will be there. Now question is what? Why this electron comes here? What are the reason why these electrons come towards the left side? And when the electron clouds are on the right side of the A atom, here, then again the B atom's electrons are also on the right side. Have you ever thought why these things happen? You know very well, electron is a negative charge particle. And electron repel each other. Now, question is about the polarizability. How this polarity will occur or how it will induce the polarity. Because electrons are negative charge particle, they repel each other. When they get a maximum distance, that time they retain their properties. Electron forces, they both are negative charge particles. So definitely they arise a force. And then they go far away from each other. So now question is about all this. These are inducing the force to each other, and they are arising the polarizability, they are arising the polarity. So this force is known as London force or dispersion force. Second one is dipole-dipole force. Now you will ask me, sir, what is this dipole-dipole force? You may have heard about the hydrogen bonding. And hydrogen bonding, you may have heard about the HF bond. Hydrogen fluoride. There are 2 types of hydrogen bonding. I hope all of you have remembered. Can you tell me what are the 2 types of hydrogen bonding? Yeah? Intermolecular hydrogen bonding and intramolecular hydrogen bonding. You're right. So there are 2 types of hydrogen bonding, intermolecular and intramolecular. We have discussed in the intermolecular hydrogen bonding. I have given you the example also, HF. HCl is not intermolecular hydrogen bonding. Now, as I have told you about the dipole-dipole forces, just think about the HCl. Here, the polarizability will be towards the chlorine. And similarly, here HCl. Again, the polarizability will be towards the chlorine. Now, since they both are very close to each other, so what will happen? You will see here, because the chlorine is highly electronegative, so here there will one force will work. This force is called dipole-dipole force. Now question you can ask me, sir, what will be the distance and what about the energy? You can ask me a question here, sir, what's about the distance? So I am telling you, at least the distance should be 500 picometer. Picometer means 500 into 10 to the power minus 12 meter. So at least this much distance should be there. R value should be at least this much. And if I talk about the energy, attraction between the two atoms, that must be inversely proportional to the radius to the power 6. This is applicable for London forces also and this dipole-dipole forces also. Now you can ask me, sir, here you have said very clearly, so can here hydrogen bonding occur? As I have already told you, hydrogen bonding will occur only with the second period elements. And that also in the highly electronegative, in the water molecules you can say, in the hydrogen fluoride you can say second period, not third period. In this third period, if anybody will ask you, so here as it moves, you know very well, here it will be delta plus and delta minus. Because already you can see here it is a polar molecules. Similarly here also delta plus and delta minus. So this both delta plus and delta minus will interact with each other and they will create a dipole-dipole force. What they will create? Dipole-dipole force. Are you getting or not? I hope all of you are getting. Now the third one is dipole-dipole induced force. Yes, it's a very nice question if I talk about dipole-dipole induced force. Just take the two dipole one which is already induced with each other, and that force you can create also one which is having a permanent dipole moment and another which is non-polar, polar and non-polar. Just talk about the polar and non-polar. Third one is polar and another is non-polar. Just think about HF. This is a polar. Cl, non-polar. Hydrogen fluoride is a polar molecule and chlorine is a non-polar molecule. Now tell me, one is dipole and another is dipole-induced force. So what will happen here? Can you tell me? Just suppose in this hydrogen fluoride, here this type of force will be there, and in chlorine, this type of force will be there. So what will happen? This chlorine will again arise against, right? So this force, dipole-dipole induced force. What is this force? Dipole-dipole induced force. As I have told you about, here there will be delta plus, delta minus. Here they both are polar or non-polar only, so the dipole moment value will be 0. Always remember the distance between the two atoms or a molecule. Just remember that at least the distance should be 500 picometer. That is radius. You can say it's a radius also. Radius between the two atoms. So this should be at least 500 picometer, not meter. 500 picometer. That is 500 into 10 to the power minus 12. And if I talk about the energy, then energy will be inversely proportional to the radius to the power 6. Remember this word. So this thing is about the intermolecular forces, which was given by a Dutch scientist known as John van der Waals. After understanding this concept about the intermolecular forces, then we are having a knowledge about hydrogen bond. As I have already told you about the hydrogen bond, can you tell me? There are two types of hydrogen bond. Yes, intermolecular hydrogen bonding and intramolecular hydrogen bonding. Right? You may have heard about this both the bond in the previous chapter, chemical bonding. So in hydrogen bonding, what happens? If I talk about intermolecular hydrogen bonding, here HF bond is there, HF bond. So here this bond is called intermolecular hydrogen bonding. And if I talk about orthonitrophenol, Just a minute. So you can just understand about the inter and intramolecular hydrogen bonding. You may have heard these things in the previous chapter, and many more concepts you may have heard also. Now there is one more thing I just want to inform you about, that if the electrons are in motion in the atoms, electrons are in the motion. They are not a stable particle, they are not static. They are always rotating around the nucleus. So if they are doing the rotation, then you know very well that they are in kinetic motion. They are in motion means which motion? Kinetic motion. Kinetic motion formula is K is equal to half into kinetic energy is equal to half mv square. You may have heard and you may have learned this thing from the 9th standard. So kinetic energy is half mv square. Right? Am I right or not? Yeah. Why I am telling you these all the things? Because of thermal energy. Our new topic is about the thermal energy. As you have right now only studied about the induced particles, intermolecular forces, the three types of intermolecular forces, that is London bond or London dispersion force, dipole-dipole force, and dipole-induced force. So now the next topic is about, what is the next topic? Can you tell me? The next topic is thermal energy. Now, just suppose this is an atom. In this atom, electrons are revolving around the nucleus. So as the electrons are revolving around the nucleus, they are in the motion. Means they are in which motion? Kinetic energy motion. That is half mv square. Right? Now, since they are in the motion, so what do you think? Which energy will create? Thermal energy. Thermal energy is created because of kinetic energy. And I have already told you kinetic energy is in random motion. It is not static. It is moving. And electrons are not static. In the atoms, electrons are not static. Am I right? Electrons are always rotating around the nucleus. So as they will rotate around the nucleus, they will be in the motion. As they will be in the motion, kinetic energy will produce half mv square because they are in the motion, and energy will give you heat. It will produce heat. That's what I am talking about, the thermal energy. If I talk about the thermal energy is the energy of a body arising from the motion of its atom or molecules. It is directly proportional to the temperature of the substances. It is measure of average kinetic energy of the particles of the matter and is thus responsible for the movement of particles. Thus, movement of particles is called thermal motion. See, just listen. Have you ever seen that your mama is cooking chapati? So just suppose this is tawa. Okay, here is your gas stove. Here is your gas chula. This is your burner. Okay, this is connected with a cylinder. See, my drawing is not good, but just trying to make you the concept. This is your tawa. What is this? Black tawa. Okay. Now, as your mama has just made chapati with the flour dough, and she had put this chapati on this tawa, right? This is your chapati or bread, whatever you speak about the chapati. In Indian language, we call it chapati. This chapati, as first time it get a little bit heat, after that your mother turn the next side. And when the next side is overall heated, then she remove the tawa and put on this gas chula. So you will see this chapati is becoming like this. And somewhere black colors where it has been, means, this is your chapati. In Hindi we call fula roti, yes? Fulki, yeah. So now, can you tell me, just I am giving you the concept, can you tell me why this chapati had expanded their shape? Means ये रोटी क्यों फूल गया? I just want to ask you that. Why this chapati has extended its shape? Because of heat. Because of heat, na? See, chapati was made up of this plain shape, this circular shape. This was your chapati earlier. When you put this chapati on the heat, on the tawa, as tawa has observed heat from the chula, and as you put on the chula, it has expanded its shape. Means it was having atoms and molecules very tightly packed. When there was a chapati, without putting on the tawa, the atoms and molecules were closely packed to each other. These atoms were closely packed with each other, right? As you put little bit water on the wheat flour, so when you make a dough, since you have put water, so it was having a little bit fluidity nature. Okay. Now as you make chapati, now the atoms are arranged. They are tightly packed. You can say it is arranged. Now, after cooking it, what will happen? As you heat this chapati, means atoms and molecules try to move. Means they are trying to be in motion. They can move any direction. One atom can go here, another atom can go here, another atom can go here. Means they try to move in any direction. As they move, the size expand, and your this chapati size become large. Got it? This is the concept of thermal energy. This is the concept of thermal energy. What I said you, the atoms were closely packed to each other. As we have heated, or we have just given heat to it, the atoms and molecules started moving each other. They were in motion, kinetic energy, half mv square. As they started moving in the motion, they have expanded their shape. So because of the thermal energy, your this chapati become fulki or fulka, whatever you say, right? Have you got the concept? Thermal energy. If you have not got the concept, this is because of temperature. The reason is temperature. As we have increased the temperature, you may have seen, as here there is one burner, as we can increase and decrease, right? So when we put into the straight position, means it is high. When we put into the low, means this vertical position and horizontal position, that the vertical is high and horizontal is low, we say seam. So, and after that, when you want to just make this chapati into fulki, then it expands its shape, because when you give the heat at the high pressure. Temperature and pressure is very much valuable. Remember this word, temperature and pressure. Temperature, pressure and volume. These three things you must remember. Temperature, pressure and volume. Because these three things are going to come ahead. As you will remember these three things, all are having relation. You have to keep one thing constant, you have to keep two things constant, and you can see that what's happening in this object, or what's happening to this gas, how it's expanding its shape and size, how it's lowering its shape and size. Have you ever thought about this LPG cylinder, liquefied petroleum gas? How they convert this petroleum gas, means petrol is a liquid, you know very well. Petrol is a liquid, now we put it to our bike and scooty. Then how have they converted this petrol into the gas? liquefied petroleum gas. Its name is only liquefied petroleum gas. In Hindi we say dravit petroleum gas. It is liquefied, and that liquefied gas convert into the gas. Liquefied petroleum gas. If you may have ever filled this cylinder, you may have seen nowadays, you will see in our Gujarat city, you are having a Gujarat gas pipelines, right? Means one, there is this petroleum tank is there, just like you may go to fill the petrol near the petrol pumps. Similarly, there is a gas, that petrol tank or petrol place. There a government have they have bought petrol from the different countries or different cities, and they supply to all over to the district or all over to the municipal corporations. So from there you get, but you have seen that how this liquefied or gas was compressed. You know very well. See here, this is a cylinder. In this cylinder, you just suppose these are the gaseous atoms. Gaseous atoms are very freely to move each other, and this was our piston. Okay. So when it was free, it was very far away from each other, right? When you increase the pressure when you have increased, means as this piston was here, it came here. Now you have increased the pressure. So now these all the atoms, when it was having a lot of enough space, they were arranged anywhere. As you have increased the pressure, now these all the atoms will come inside this only. Are you getting or not? So how you understand about this concept? Similarly, all the liquefied petroleum has. Have you ever taken a DO? Yes. When we go for parties or anywhere in the function, we put DO in our body. Setwet, Setmax, many more DOs companies are there. So have you ever thought, when you just put at your hand, you will see it is in the liquid. But as it comes in the contact of air, it evaporates. It is not wet for maximum than 5 or 2 minutes, as it reacts with the oxygen and it evaporates. Diffusion, the word diffusion you may have heard in the 9th standard. Your mama is cooking paneer in her kitchen and you get smell. Oh wow, mama is cooking paneer. These are the examples of chemistry, diffusion. You have taken a body spray in your room and your papa has said, hey, why are you using my perfume? You understand? Right? So what I want to say you is, this whole chapter is related to the temperature, pressure and volume. You may understand by increasing the temperature or by decreasing the temperature what will happen to the atoms and molecules. By increasing the pressure and decreasing the pressure, what will happen to the atoms and molecules. And when we have a lot of enough space, means greater the volume, what will be the effect on temperature and pressure. And if we have a less volume, what will be the effect of temperature and pressure. These are all the things we are going to study in this chapter. First of all, predominance of the thermal energy. As you know very well, we can convert gas to liquid and liquid to solid. You know very well. Similarly, solid to liquid and liquid to gas. What is this? It is predominance of thermal energy. So this thing you must remember. Now we will talk about the gaseous state. Have you ever thought LPG is made up of which chemical? I hope many of you know also that chemical name, but just pause the video, give a pressure on your mind and tell me, before I say the answer, put into the comment box section that which gas is present in the LPG. Just pause this video for a second. Pause this video and write into the comment box section that which gas is present in LPG. I hope all of you have written that's N-butane, normal butane. What is the formula of normal butane? The single line for carbon. 1, 2, 3, 4. C4H10, right? Or H12. C4H10. Yes, CnH2n. It's normal butane. Its name is normal butane. It is present in LPG gas. I know all of you have written correct, not an issue. But what I want to say you that, have you ever thought that gaseous can mix with another gases in the atmosphere? Have you ever thought? कभी आपने सोचा है कि मतलब इतने जो environment में गैस है, they can mix with each other, और mix होकर के क्या बनते हैं? What they form means, what they yield, what is the product, what is the name of that product? Just I am giving you one more example. Sometimes you will see that we get a very bad smell. So what? We take out our pocket perfume, we spray on our hand. Ah, now it's relaxed. Means what you have done. Have you ever thought what you have done? You have mixed the gases. You have mixed one bad smell gases was there, and you have put a good smell, good fragrance one, and you have mixed both the gases. The density was higher of this good fragrance gases, and it has removed your bad smell. You may have seen in the summer season, the persons are getting a lot of sweats. Yeah, actually I also get a lot of sweat, but as we know, sometimes sweat gives very bad smell. So what we use body spray. We put body spray in our body. After then we wear a shirt, we wear uniforms, and then we move to school as we are younger. And some persons don't like perfume. That also I know, because the perfumes are also of two types. One is hard perfume and one is soft perfume. Generally girls or ladies use soft perfume, and the gents use hard strong perfumes. Means it's a very hard smell perfume. Means if you put a hard perfume, then it will remain for at least 2 to 4 hours. But when you put a soft perfume, means they can be easily diffused, or they can easily mix with another gases. Soft perfume means that it can easily mix into the air, it can react with the air, and it can convert, it can fly away into the world. So remember, whatever I want to say to you, that there is a focused attachment of the different gases present in the nature. What are the gases, and what's about these things as I'm talking about? This is the simplest state of matter. It is the gases, and if I talk about the mixture of the gases, gases can be highly compressible. Yes, gases can be highly compressible or not. We can compress the gas very tightly. Gases exert pressure equally in all the directions. We can compress, as I have told you, in this cylinder I have compressed the gases. Gases exert pressure in all the directions. Gases have much lower density than all the solids and liquids. The volume of the gases can be changed according to the shape. Yes? And gases mix evenly and completely in all the proportion without any mechanical add, you can see, without any mechanical force, you can see. So now, what is the concept? Means, when we study about the gases, we get a different things. There are 3 scientists which have given these things. First one was Charles. Boyle's law, Charles' law, and Avogadro's law. Boyle's law about the pressure and volume relation, temperature constant. Charles' law, if I talk about the Charles' law, pressure and temperature, and if I talk about the Charles' law, then I am telling you that it is a relation of volume and temperature. And if I talk about the Avogadro's law, it is the volume and number of atoms. If I talk about the Gay-Lussac law, pressure and temperature. So there are many scientists which have given the laws about these things, that what will be the effect of temperature, pressure, number of atoms, what will put 2 things constant, one thing if we leave, then what things will happen. These are all the things I am going to teach you. But one by one, we should understand the concept. First of all, what things we have learned? One more time, intermolecular forces, 3 types, right? Dispersion or London force, dipole-dipole, and dipole-induced force. After that we have heard about the thermal energy. After the thermal energy, I have told you about the gaseous states, that mostly the gases nature, about which nature do gases have and what are the properties do gas have. Now we are going to discuss about this all the gas laws. So first of all, I would like to tell you about these scientists. Have you seen a hot air balloon? Have you noticed about the hot air balloon? How the number of atoms and molecules increases, volume increases, temperature increases or decreases, pressure increases or decreases, volume increases or decreases. Have you ever seen a hot air balloon or not? First tell me that. As I know that all of you have seen about the hot air balloon, there was one scientist known as Boyle. What was his name? Boyle. B-O-Y-L-E. Boyle. In 1662. Which year? In 16. See, I'm telling you one more thing. Education has not been started right now. It was started very earlier. So, this gas law, the first scientist was Boyle. Gas law. What is the topic name? Our topic name is gas laws. The gas laws. First was Boyle. What he had said, he had just thought that what will be the relation of pressure and volume if we keep temperature constant. Means temperature is constant, whatever the temperature I was giving, the same amount of temperature. Temperature is not either increasing or decreasing. Temperature is constant. Then what will be the effect on pressure and volume? He said that pressure is inversely proportional to volume. What pressure Boyle said? Pressure is inversely proportional to volume when the temperature is constant. Means as you increase the pressure, volume will decrease. As I have shown you also, this is the cylinder. As I have said, these are the gases. Since gases are free to move each other, this was the point, here was the piston, right? So there was a little bit pressure. As I increase the pressure, and I put the piston from here to here, so now all the atoms and molecules came here. Means, you can see here, after increasing the pressure, as I increased the pressure, the volume started decreasing. So Boyle had not said a great thing, he had just said that he had done a lot of experiment, temperature, pressure and the number of atoms. He had just seen after the experiment, he have given a conclusion that pressure is inversely proportional of volume. As we increase the pressure, volume will decrease. As we decrease the pressure, volume will increase. You may have seen, I am giving you the example of this pressure and volume. You will see, as the teacher scold to the student, teacher give pressure to the student, automatically all the volume will be silent. Means whole mass, all the students will be shh. Means pressure increased, teacher's pressure increased in the classroom. Either a lot of volume was there, but it was looking like it is very minimum. But as the teacher decreased the pressure, teacher tried to laugh at the student. You will see all the students are making noise. They are talking with each other. They are gossiping with each other. Means volume is low. Everywhere you will see the noise is coming. Volume has been increased. So remember this word as the Boyle had said. Pressure is inversely proportional to volume. When temperature is constant. Remember this word. As we remove this proportional, then we have to give some constant. P is equal to K into 1 by V. Can we give this or not? Definitely we can give. So P is equal to K by V, or PV is equal to K. Can we write or not? Tell me. Can we write this equation? As according to the concept, PV is equal to K. What is this K? K is constant. P is pressure and V is volume. So here you have seen that what's the relation about the pressure and volume. So if I talk about, just suppose P1 by P2 is equal to, here 1 upon V1 by V2. So what will happen? P1 by P2 is equal to V2 by V1. Right? So cross multiplication, P1 V1 is equal to P2 V2. Is it right or wrong? Tell me. Is it right or wrong? It is right. So you have seen the relationship between the pressure and volume which was given by Boyle in 1662. So after understanding this concept, that what are the relation between the pressure and volume in gases, now it is also known as isotherm, constant temperature. Constant means equal, iso, T-H-E-R-M, heat, temperature, isotherm. It is also known as isotherm. Iso means equally, ek jaisa, right? Isotherm. So I hope all of you understand about the Boyle's law. What do you think? We should learn the Charles law and Lussac law, or we should leave for today? Just remember these things. If you want to take a screenshot, then you can take a screenshot, or if you want to make a notes, then you can make a notes also. Is it visible to everyone? Yeah, I hope it is visible. Yeah. Now we will move towards the Charles law. What is the relationship between the Charles law? Now, after understanding the concept of, okay, one more thing I would like to tell you. Volume is also relation having with density. Density is equal to mass by volume, right? Means you can say density is also inversely proportional to volume. If the volume will increase, then density will decrease, or if the density will increase, the volume will decrease, right? Are you getting or not? Density, you can say that as the density will increase, the mass will also increase. Means directly proportional. Mass will increase, density will also increase. But if the density will increase, then volume will decrease, or volume will increase, then density will also decrease. So remember these things, you must remember. And after understanding this concept, we'll move towards the second concept, that is Charles law. When the temperature and volume relation we are putting. Now the second law is Charles law, temperature volume relationship. Charles law. Temperature volume relationship. So can you tell me what will happen temperature and volume? If we increase the temperature, volume will increase or decrease? So Charles and Gay-Lussac law had done a lot of experiment on that hot air balloon. Hot air balloon. See, I just want to tell you one thing, that many students get confusion that, sir, what will be the relation? It will be directly proportional or it will be inversely proportional. Many students ask to me that, sir, what happens if it is having a fixed mass of a gases at constant temperature or pressure, or the volume of a gas also increase, but as we increase the temperature or decrease on cooling, they found that each degree rise in temperature and the volume of a gas is also increased. Means temperature is also directly proportional to volume. Means as we increase the temperature, the volume also increases. I had given you the example of the chapati. Have you heard the chapati one or not? Means per degree, as we increase the temperature, the volume is also increasing. So here they have given a formula in your NCERT that at an absolute temperature 0 degree Celsius, if I talk about, so here they have just given Vt is equal to V0 plus the temperature upon 273 Kelvin, and this much it will increase. How much it will increase? This much. So as the temperature T we are increasing, this much increase in that. Means if we give temperature to the volume, this degree will increase. Right? So what will be the relation? Can you tell me? So you can understand that we can write here that Vt is equal to V0 into T1 upon T0. Now you can ask me, sir, what is this T1, T0? Absolute 273 degree Kelvin means 0 degree Celsius, and whatever the temperature has been increased. Right? Can we write or not? So if I talk about, then can we put here Vt by V0 or equal to T1 by T0? Can we write this or not? So what you have seen here, just remember, as we have increased the temperature, the volume has also increased. When there was a temperature T1, that was V1, and when it became T2, it became V2. It has become or not? So if I talk about the second volume upon first volume, then you can write second temperature upon first temperature. Can we write or not? Just tell me. So what you have seen, that volume upon temperature is constant. Volume upon temperature is equal to constant. So this law was given by Charles law. Whose law? Charles law. And there was a last law given by Lussac. It was pressure and temperature. At a constant volume, what will be the relation between the pressure and temperature? Lussac law. Lussac law. He had directly told pressure is directly proportional to temperature when V is equal to constant. Means P is equal to KT. Means P by T is equal to K. Means P1 by T1 is equal to P2 by V2 T2. So P1 T1 is equal to P2 T2. P1 T2 is equal to P2 T1. Right? So these three gaseous law in more detail we will also learn. See, one was isotherm, this is isochore, and if I talk about this temperature one is isobar. That was isotherm, this is isobar, and that is isochore. See, whenever you understand any topic, that time try to just make examples in your mind. So what will happen, as you find some examples, you will get a concept. Oh, really? In this pressure and temperature, pressure, temperature, what will happen to the volume? Volume will remain constant. It was the Lussac law. As we have just given the relation of temperature and volume, it was given by Charles. And what about P1, V1, P2, V2? That was the point. So remember, whenever you are arising any concept, how this constant came, how this proportional came, this example must be in your mind. I hope all of you have enjoyed this video. If you have liked this video, then don't forget to like and subscribe the channel. Share this video with your friends so they can be also enjoyed. If you have any doubt, then please put your doubt into the comment box section. That's all for today. Thank you very much. Stay at home, stay safe. Thank you.